right, ladies and gentlemen, I'm going to be starting the next day for Calculus Power Series, Geometric, Taylor, that whole thing that we've been working on before. The thing that I'm going to start off with is that I'm actually live right on Discord at the moment. So I'm trying this new thing where I'm able to teach live, where people can ask questions, but then I'll eventually upload the video to YouTube so that you guys can kind of see what's happening here. Maybe at one point I'll actually end up putting like my face up on the screen as well as I'm actually teaching. So let's get started. So if I'm working with, let's say, a geometric series, so n is going to be equal to 0, goes to infinity. That's going to be a sub 1, or a sub just a, r to the n power. Now before we talked about when the n value started at 1, now we're just pretty much, right, we're just now going to start n is going to be equal to 0. So if I gave you an example of what this specifically looks like, if a is equal to 2, for example, or a sub 1, and r is going to be equal to 3, then I would set up the series in a sense to be 2 plus 6 plus 18 plus 54 plus dot 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 dot, and then plus 2 times 3 to the n power, and plus dot 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 for my general term. If I were to give you an example that looks like this, a is going to be equal to, let's say, 1, but r is going to be equal to, let's say, x. Then I could say that this is actually just going to be 1 plus x squared plus x to the third plus x to the fourth plus dot 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 plus x to the n. And then that continues going on forever. Right, and so the setup for these geometric series makes for some interesting kind of conversations when I'm dealing with some of the power series in relationship to that specific type of function. So we remember before, if I have some type of n is equal to 0 goes to infinity of a times r to the n, I can also say that it converges to the sum a over 1 minus r if the absolute value of r is going to be less than 1. Now, if the absolute value of r is going to be greater than 1, or greater than or equal to 1, the series diverges. And we talked about that before. Talked about whether a geometric series diverges or converges. Okay, so the idea is what we're going to be doing is we're going to be taking, in a sense, this summation right here and working backwards. So we're going to take this and actually rewrite it like that. So, weirdly enough, if I have 1 over 1 minus x, that's going to be equal to, in a sense, the Taylor series or the power series. It's going to just be 1 plus x squared plus x to the third plus x to the fourth plus so on and so forth plus x to the n plus dot 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 dot. And we can actually organize that in terms of Taylor, but we don't need to because I'm basically giving it to you. So if I give you an example that looks like this, ready? F of x is equal to 1 over 1 minus x squared, and then I'm going to say centered at x is equal to 0. Now we remember the stuff before in terms of centered. We're going to go into more kind of details about that later. But let's say that I want the first four non-zero terms and then a general term. So I have to take a look at this specific function right here and kind of pull out the a value and pull out the r. So if I look at a sub 1 is going to just be 1, and r is actually going to be x squared. Now, with the look of this, right, I can rewrite it kind of similar to that. So I'm going to write it as 1 over 1 minus, in a sense, x squared. And then that's going to be 1 plus parentheses x squared plus parentheses x squared to the second power plus parentheses x squared to the third power, so on and so forth. And then I would actually rewrite this as 1 plus x squared plus x to the fourth plus x to the sixth plus dot 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 dot, and then plus x to the, in a sense, 2n, and then plus dot 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 dot. And so this gives us our first 4 non-zero terms. This gives our general term. Now, if I were to ask, where does the series converge? So, when does it converge? And in this case, it's going to converge when, in a sense, the absolute value of x squared is going to be less than 1. Now, we know that a value that is, in a sense, x squared is actually going to be positive, so the absolute value stuff can actually go away. And so we also think about when is x squared going to be equal to or less than 1? And we know that some of the values, right, if I end up placing in, let's say, 1, it satisfies this. Pretty much what we're doing here is we're going to end up doing this piece. So x squared minus 1 is less than 0. Then we're going to do x plus 1, and x minus 1 is less than 0. We do our nice little table. Negative 1, 1 are going to be my points. They're going to be open circles. And then figure out where it's shaded. And in this case, it's actually going to be shaded between negative 1 and 1. So converges from negative 1 to 1. Now, if I actually take a look at what this looks like in terms of the graph comparing to the first 4 terms, so what I'm going to do here is I'm going to graph these terms, and I'm also going to graph this equation right here, or the original equation in a sense. So if I take a look at Desmos, I can see 1 over 1 minus x squared, and I can see that gives me this specific type of shape. Now with this specific type of shape, right, it doesn't kind of give you very much information, but if I compare it to the Taylor series, or the power series, I can see that actually if you take a look at just the blue, right, it kind of gets the end bounds out of the way. But if you look at the middle is actually very, very similar to it. So it's kind of that same thing that we talked about in terms of saying that the Taylor series is sort of the same as the partial sum, which is kind of interesting. Anyway, going back. Okay, next problem. Let's say I give you a problem that looks like this. So example, f of x is equal to 12 over 4 plus x, and then we're still going to be centered when x is equal to 0. Okay, first 4 terms, non-zero terms, and then where does it actually converge? So we're going to write down a is going to be equal to, well, actually, before I do anything, I want to try and kind of rewrite this, this function a little bit. So I'm going to rewrite f of x is going to be equal to 12 over 4 plus x. Now, one of the things that you'll notice with some of the other, the summation for a geometric series, we can take this 4 right here, right? And that 4 is normally supposed to be a 1. So what I'm going to do here is I'm going to take the numerator, divide by 3, divide by 3. And I end up getting 4, not divide by 3, divide by 4. Divide by 4, divide by 4. So I end up getting 3 over, and then 4 divided by 4, which is going to give me 1 plus x over 4. Okay, so that kind of clears up a little bit about like a is going to be equal to 1, a is going to be equal to 3. Now r is going to be actually equal to, well, if I rewrite this, 3 over 1 minus, and then we need to write out what our r value is supposed to be. And in this case, it's going to be negative x over 4. Okay. Let's see. Oh, wow. Holy crap. I didn't even realize that there's a ton of people in the chat. All right. Hi, people. All right. Getting back to things. So if I take a look at this, I'm going to get r is equal to negative x over 4. And then when I kind of set up the whole problem here, I'm going to start it off by saying, well, 12 over 4 plus x is going to be equal to. Now I look back at my series right here, and I can kind of see how this is actually broken down. So I'm going to start off with, in a sense, the 3. And then I'm going to do minus, because my r value is negative, and I'm going to do 3 parentheses x over 4. Actually, you know what I'll do? I'll still set it up as, put this plus and put that as negative in there. And then plus 3 parentheses negative x over 4 to the second power, plus 3 parentheses negative x over 4 to the third power, and so forth. And if I actually evaluate that, that's going to be 3 minus 3 parentheses x over, actually I'll write it as 3/4 x. And then this is going to be positive. This is going to be 3 over 16, x to the second, minus 3 over, what's this, 64? 64x to the third, plus dot, 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 dot. And then I can see how this is changing each time. I'm going to say plus 3 parentheses negative x over 4 to the n power, plus dot, 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 dot. Okay, so that's, in a sense, my geometric series that's relating to it. Now I need to try to figure out where does it converge. So I'm going to do the absolute value of r is going to be less than 1. So the absolute value of negative x over 4 is going to be less than 1. The negative goes away because of the whole absolute value. So I'm still going to say negative 1 is less than x over 4, which is less than 1. And so then it converges from negative 4 to 4. So that's when it converges. That specific series, or power series. All right, and the last problem. So I'm going to write this as f of x is equal to 5 over 4 minus x. And then this time I'm going to say that it's going to be centered at x is equal to 3. Now the only difference here is that I'm pretty much trying to get a parentheses that is going to be x minus 3 in the denominator that's going to stand in the place of r. Because what's going to end up happening is I know that I'm going to have some type of a parentheses x minus whatever it's centered at 3 to the first plus a parentheses x minus 3 centered at 2 plus dot, 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 dot. Now, I can't just assume that that first number is going to be 5. It is in this case, but we just can't assume that to begin with. So I'm going to rewrite my problem. I'm going to write this as 5 over 4 minus x is equal to 5 over, and then what we want to do here is we want to rewrite this problem in a way that helps us get, in a sense, a parenthesis x minus 3. Okay, so we still have a positive 4 value, and if I'm subtracting right here to get this whole x minus 3, I need to have something on the end right here to have it still be equivalent to 4 minus x. So if I think about how I distribute this, right, I'm going to end up getting a positive 3. Well, I just can't have a positive 3 just in the denominator, so I'm going to have to add in also a negative 3 to help us combat that kind of change in values because, right, we need to just make sure that we're adding by 0. Okay, so moving on from here, I'm going to write this as 5 over 1 minus parentheses x minus 3. And then basically I still get that whole form a over 1 minus r. So a is going to be equal to 5, r is going to be equal to x minus 3. And then in this case, that sets up the whole problem to be 5 plus 5 parentheses x minus 3 plus 5 parentheses x minus 3 to the second power plus dot, 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 dot. And then where does this converge? It's going to converge on the absolute value of x minus 3 is less than 1. So we'd say negative 1 is less than x minus 3, which is less than 1. So I'm going to get 2 is less than x minus 4, which is less than 4. Okay, and that is it for the lesson. I'm going to be turning off the stream or the saving of the videos if you guys want to ask me any types of questions at the end as soon as I hit stop. I'll see you guys later.